This is Unit 6, Video 4, specific heat or heat capacity. So when we're dealing with changing the temperature of a substance that requires maybe a lot of energy or not a lot of energy, we're going to use something called specific heat. So what specific heat it represents, or heat capacity, represents how much heat or how much energy is required to change the temperature from an initial temperature to a final temperature. So if we look at the equation for specific heat, it's going to be S equals Q. So S is going to represent our specific heat, equals Q, which is our energy, or joules. Normally you're going to see heat, divided by mass times the change in temperature. Okay, and key here is change in temperature, because we're starting with an initial temperature and we're going to a final temperature. Okay, the easier way to write this equation is in the linear form, which is Q equals Sn delta T, and L is represented by mass, so we do not need to convert anything into moles. Okay, specific heat deals directly with the mass, how much of it we have in order to change the temperature. Okay, so let's look at a problem here. Say what mass of aluminum is present if 1015 joules of heat, so that's how much energy we had to put in, changes the temperature from 25 to 75 degrees Celsius. Okay, so here I've given you Q, so this is our Q here. Okay, I've given you two temperatures, so this is going to be our delta T. Okay, I'm asking for mass, so this is going to be our M. So the only other thing we're missing is specific heat, which has to be given to you if I'm asking for mass. So here the specific heat of aluminum is 0.900 joules divided by grams degrees Celsius. So all we're going to do now is plug into our equation. So we have our Q. Q is 1015 joules. Okay, we have our specific heat, which is 0.900 joules gram degrees Celsius, okay, times our mass, which I'm just going to give mass an M, and then change our change in temperature. So change in temperature is final minus initial. So my final temperature, okay, from means what I started from, to is what I ended up with. So 75 minus 25 degrees Celsius. Okay, and we can leave this unit, per specific heat, we need to leave the temperature in Celsius. Do not convert it to Kelvin. Okay, so if we were to rearrange all of this to solve for M and punch all of this into your calculator, you would get M equals 1015 joules divided by 0.900 times 75 minus 25, which is 50. So we can just say times 50. Okay, if you were to punch all of this into your calculator, you would get that the mass of aluminum needed to raise the temperature from 25 to 75, if we put in that much energy, is going to be 22.6 grams. Okay, so now let's do a different one. Let's go through where we calculate the specific heat, so the specific heat isn't given to you. So here it says, what is the specific heat of silver? So we're solving for S here. If 472 joules, so this is going to be Q. Okay, change from 10, okay, so 10 grams is my mass. So we change 10 grams from 25 to 222. So this is going to be my delta T. Okay, so we've got everything we need, so we're just going to plug it into our equation. So my Q is 472. So Q equals S, which we're going to solve for the specific heat of silver, times the mass, which is given to you. It's in 10 grams. It needs to be in grams, okay, because specific heat is given in grams, times my change in temperature, which is final minus initial. So my final is 222. My initial is 25. Okay, if we were to get this by itself, we're going to take 472 and divide by these two multiplied together. So if you punch all of this into your calculator, you're going to get that the specific heat of silver is equal to 0.240 joules divided by grams degrees Celsius.